Hi everyone, so today we'll be learning more about the titration practical. So by the end of this lesson, you will be able to understand the concept behind titration, also be able to identify the different color changes that happens during titration, understand that titration is a very sensitive procedure and therefore will require a lot of sensitivity. Also understand the flow of the different experiments that we need to do in the titration, which includes the rough titration as well as the accurate titration, which can be split into two sections. Firstly, the fast addition, and then followed by the drop-by-drop section. So what is titration? So titration is used to measure the amount of substances. So for example, how much hydrochloric acid is actually inside, let's say, this bottle. So what do? We use an experiment that we know that reacts hydrochloric acid. So for example, this neutralization experiment. So we put the hydrochloric acid inside the conical flask and we titrate it with the sodium hydroxide. We basically find out how much sodium hydroxide is required to fully react with all the hydrochloric acid, and then with calculations we should be able to find out how much hydrochloric acid that's actually inside the bottle. So as we know, hydrochloric acid is colorless, sodium hydroxide is colorless, sodium chloride is colorless, water is colorless. So we actually cannot see when does the reaction finish. So therefore we actually need to add an indicator which will give us the color change at the end of the reaction. So color changes in titration is actually very important. So an example is that if I add universal indicator in the conical flask at the start of the reaction, the hydrochloric acid would be inside the conical flask, right? And at the end of the experiment, there will be the sodium hydroxide and the water, which will be inside the conical flask. So the start of the reaction, the universal indicator will be red, and the end of the reaction is when all the hydrochloric acid has been reacted finished. So if all the hydrochloric acid has been reacted finished, the ending mixture in the conical flask will therefore have to be green, right? So if you look at this diagram over here, the start of the reaction will be red. At the end point, that means the end of the reaction, that's what we call the end point, it will be green. And if you add too much sodium hydroxide, suddenly the universal indicator will become blue and then purple. Right? So it's very important for us to understand that in this titration, if we use universal indicator, the starting will be red, we will add the solution until it's green, exactly as green, and if we add too much, it will become blue. So this is why the sensitivity of the titration experiment is so sensitive, because from the red color to the green color, all you need is actually one drop, and then it will turn permanently green. And for the green, all it takes is just another drop to turn it blue. So we actually only have a few drops difference for us to make sure that we get that number exactly correct. And that is why titration is such a powerful experiment. So another color change, right, in this particular experiment that you'll be watching the videos on, it's the titration between iron 2 sulfate and potassium manganate. So iron 2 sulfate is light yellow and it will be found inside the conical flask, and potassium manganate is dark purple and it will be inside the burette. So when the reaction starts, the conical flask will be light yellow, which is the iron 2 sulfate, and then if we keep adding the potassium manganate and if we exceed, it will be purple. Alright, so you must understand this. Before it's yellow, if I exceed, it's purple, and the end point will be the color that's the mixture between the light yellow and the purple, sorry, which would be the light pink, and that is the end point. So I repeat, before it's light yellow, beyond is purple, and the end point will be light pink. So taking a note, it takes only one drop to turn from the yellow to the pink, and then it only takes another drop to form the light pink to form the purple. But what we want is actually the light pink. So our titration method we use is that in one way, right, because it's so sensitive, we can actually start from start to finish, right, adding drop by drop. But that is actually very inefficient, right? So what we do over here is that we use the rough titration method. So let me give you an example. This is one method. I have the starting point. That means I never add anything yet. And let's say, for example, I add drop by drop by drop by drop by drop from the start until I hit the correct color, which is maybe like light pink, right? Oh, but you know how much time I take just to add drop by drop by drop so that I won't miss the light pink? And that color change would therefore be my endpoint, but this endpoint is not known to us. So that's why adding drop by drop is really very inefficient. So what we do instead is that we do a rough titration. That means the endpoint is not known to us, right? We just run the mixture all the way in until it turns this like pink. We might have overshot a lot, right? So let's say, for example, my rough titration according to this is 23.30 centimeter cube, right? And it has turned light pink for a duration. I'm not so sure exactly, but what I know is that because I overshot, and 23.30 is an overshot value, the endpoint cannot be more than 23.30. It has to be less than 23.0. So then I will decide what is like a comfortable number for me. So I will assume that maybe the endpoint is between let's say 21.30 and 23.30. This is like maybe the range that I think I'm comfortable with. And then the 21.30 will be sort of now like the trigger reading. So that's our rough reading. So what we do then is that instead of going drop by drop by drop from start all the way to end, I do a very fast addition from the start all the way to the trigger reading, which is in this case 21.30, right? All the way very fast. And then when I'm very close to the endpoint, because I know it's roughly around here, I'll add drop by drop by drop by drop until I reach the endpoint. And then, this is the endpoint, and I record down my reading. So by doing the rough titration, then the accurate titration in two different steps, we actually save time, one, but yet get a very accurate result. So what is the flow of events during a titration experiment? So the order of titration is first, we do an experimental setup, and then we draw our titration table. We make sure we prepare the conical flask. We make sure we prepare the pipette. We prepare the burette. And then after that, we do the rough titration, and then we do the accurate titration. So now the only step that needs to be repeated is keep doing the accurate titration until we get this thing what we call the two concordant results, which I will teach you what is it about in the future. And then finally, after I finish step 1 to step 7, I'll do my data processing. So I've prepared videos for you for all of these different steps. So hope that it will be a good step-by-step instruction for you, and wish you all the best into mastering this skill, the titration skill. Right? All the best. Bye-bye.